Hello, welcome to mathematics session. In this session, we are going to look at reducing fractions. This is in an attempt to uh, eliminate uh, slight mistakes that you make, and most of these mistakes are made towards the end of your calculation or towards providing an answer in mathematics. So it's important that we safeguard all the necessary marks, okay, so that we get any mathematical problem correct. So the tips are as follows. Reduce all fractions to their lowest terms. If you are dealing with a question calculation in mathematics and you end up having a fraction as an answer, make sure that that fraction of yours is reduced to lowest terms. To lowest terms means that there is no number common factor between the two numbers, the numerator and the denominator, that can go in that fraction. Okay, you have more like reached the dead end. So reduce and leave the answers to improper fractions to lowest mixed numbers. So if you happen to have a fraction which is an improper at the end or towards the end of your calculation, make sure that that fraction of yours is not improper, meaning the bigger number. Okay, if the bigger number is on top as the numerator, you shouldn't assume that is your answer or that is the final answer. Reduce to mixed and the lowest terms. Fractions with different signs. If you have fractions with negative numbers, fractions with different signs will result in a negative fractional answer. Fractions with the same signs will result in positive fractional answers. So we'll see as we go on what I mean. Then procedure 1, like factors. So to divide or to reduce a fraction, look for like factors, which is the greatest common factor. Okay, so divide both numbers and both the numerator and the denominator of the fraction to be reduced by the greatest common factor, GCF. So what is this numerator and what is this denominator? So a number, okay, if we have A over B, the number on top here is the numerator. Then the number down here is called the denominator. Okay, so that's what it is. So reduce the following fractions to their lowest terms, or reduce the following fractions. So these three you are seeing here is the numerator, this is the denominator. So how do you reduce the numbers to lowest terms? Find the number which is the greatest common, the biggest common factor of both the numerator and denominator. So which number can go into 3 and the same number can go into 6 without leaving a remainder? 3 itself. So what do you do? So this is similar to 3 divide by 3 and 6 divide by 3. So I've used the same number to divide so that I can reduce this fraction. So 3 into 3. How many times can 3 go into 3 itself? Is 1. So here we have 1 over. How many times can 3 go into 6? So you have the basic grade 4 mathematics there. 1, 2, 3, 4, 5, 6. Okay. Then you divide 3. 1, 2, 3. Like this. 1, 2, 3. So how many times has it gone there? 2 times. So here this is 2. So use any possible means to help you find the answer. Okay. Then we go to this one. This is similar to this one, but the difference is that this one has a negative. This one, there is no negative, meaning this is positive 6. So what do you do? 3 into 3 itself, we have 1. 3 into this, that is it, we have 2. So the one number is as negative, so it will result in it will result in, the fraction will result in a negative. So fractions with different signs will result in a negative fractional answer. So in this case, what do? You put the negative in the middle like this. So this is the answer. Then this one is similar to this, but what we have here, we have same signs. Same signs will result into positive. So what it means is that negative divided by negative, it will result in what? Positive answer. Positive divided by positive, it will result in what? Positive answer. So dividing with same signs will result in positive. So you can, this one cancels this one cancels this one. Then we have that is 1, 3 into 3, 1, then 3 into 6, that is 2. So this is the answer. So this is how. So don't leave out rules for integers as we go on through various topics. Don't study those integer rules as a single independent topic. Carry forward wherever you go. So we are applying throughout. So as we go on through different topics, we will be using the same things. When you are dividing numbers with different signs, negative. Dividing with the same signs, that is positive. So you are multiplying numbers with same signs, positive. Different numbers, numbers with different signs, negative. So those rules, you carry them forward. Okay, so when you see a question, mathematical question, put that at the back of your mind. Okay, what do I know about signs? If possible, you can write these tips in this format: negative divided by negative, positive, positive divided by positive, as you are practicing. But in an exam, you don't need this, because by then you would have understood and internalized these concepts. So there is not. But as you are solving through quizzes and exercises and tests, you first thing, you write this. For division, for multiplication, and for addition, you write those principles. So we go to the next example. When you have numerator and denominator having same number, okay, 6 divided by 6 is not equal to 0, please. Okay, this is terribly wrong. So what do? Which number can go into both number without leaving a remainder? It's the 6 itself. So 6 divided by 6 and the 6 divided by 6, like this, equals. So how many times can 6 go into 6 itself? It's one time. Okay, it's one time. So here it's 1, over here is 1. So when you have such a number, 1 over 1, you can't leave this as an answer. The final answer will be just a whole number 1, like this. So 1 divided by 1, 1. Okay, same number, 6 divided by 6, 1. That's the answer. So we go to the next one. When you have mixed improper fraction. So this is improper fraction because the smaller number is more like lifting the bigger number in literal terms is on top. So your answer, if you, this is common when you come to coordinate geometry. So we have this. So in this case, what do? You divide. How many times can 2 go into 15? It's 7 times, and the remainder will be 1. So that remainder becomes your numerator, and the denominator you maintain the same, what you are seeing here, like this. So this is the answer. We can get back to this. This time, this 14 plus 2, 15 over 2. So this is the lowest term of a mixed fraction. Okay, so that is the lowest term of a mixed fraction. So from the tip number 2, reduce and leave the answers to improper fractions to lowest mixed number. So lowest mixed number, meaning that this one is a whole number, it's not of our business now. So lowest, if we had the 3 here and the 6 here, okay, if we had the, for example, 7, then 3 and 6, for example. So if you leave the answer like this, it's not complete, okay, you lose marks. So we could have done this. So this 7 will not be reduced, it will be carried forward like this. Then what we are going to reduce is this one. So 3 divided by 3, 6 divided by 3. So there is 1 and there is 2. So this could have been your final answer like that. That is lowest mixed number. We go to the next one. We have 4 into 15. 4 into 15, that is 3 times. It's 3 times, okay, which is 4 times 3, that is 12. 12, 13, 14, 15. So we have 3 as a remainder there, and we maintain the denominator. So this is the answer. So this is lowest term of a mixed fraction, because there is no number that can go into 3 and 4 without leaving a remainder apart from 1. So 1 has no effect, because if you say 3 divided by 1, it will give you 3. 4 divided by 1, it will give you 4. So this is the answer. We come to this one. We have this answer. We have which number can go into 36 and 48 without leaving a remainder? So we can say 36 divided by 12, and we have 48 divided by 12. So 36, 12 into 36, that is equal to 3 times, that is 3 times. Then 48 divided by 48 divided by 12, that is 4 times. So this is the answer. Now these numbers are big. Suppose you didn't know what to do with these numbers, you didn't know that 12 can go into both numbers. What do you do? So we have 36, you can say 36 over 48. Okay, so what do you do here now? You divide, you find a smaller number that you can deal with. So if you look at the last number, 6 here and 4 here, they are even numbers, so 2 can go there. So in this case, 36 divided by 2 over 36 divided by 2. So in this case, 2 there, that is 1, remainder 1, put there, that is 16, that is 8. 2 there, that is 1. Okay, so this is 48, sorry. 2 there, this is 2 into 4, and 2 there, that is sorry, this is 48. 2 there, 36 over 48. So 2 there, that is 2. 2 there, that is 4. So if you look at this, the last number 8 and 4, they are even numbers, so 2 can still go there. So you say 18 over 24. 24 divide by 2, divide by 2. So in this case, this will be 2 into 18, that is 9. Then 2 into 2, 1, 2 into, that is 12. So when we reach this far, if you look at 2, can no longer go there. This is even number, this is an odd number. So in this case, we find another factor that can go into this without leaving a remainder. So in this case, 3 there. So 3 divided by 3, divided by 3. So 3 into 9, that is 3 over 3 into 12, that is 4. So it's the same the answer that I found here. So you do this if you don't know the numbers are big, you use a smaller factor to divide into both, so that you reduce. When you reach a dead end, meaning that factor can no longer go into the new numbers, the denominator and the denominator, look for another common factor. But if there isn't, that will be your answer. So this is basically what you are supposed to do. So we look at more examples. Procedure number 2. So Procedure number 2, list factors of each number and pick the greatest common factor and divide. So we look at the next method, the method number 2. So 15 divided by 24. So what do you do to find the number that can go into both? So you don't know. So what do you do? So if you look at 15, I'll write here 15. The factor 1 can go into 15, 2 cannot go there, 3 can go there, and 5, then 15 itself. Then we have 24. 24, 1 can go there, 2 can go there, and 3 can go there, 5 can't go there, okay, 6 can go there, 7 cannot go there, 8 can go there, then 9 cannot go there, 10 cannot go there, so we have 24. 12 can go there, sorry, 12 can go there, and 24. Immediately you reach the half of the number, the next number is the number itself. So you find the greatest common factor. So 1 and 1 is common, but it's not the greatest. 2 is not common. 3 is common. This 3 is common. We don't have any here. So we are going to use 3 to divide. So you say divide by 3. You divide by 3. So in this case, what we have, 3 into 15 is 5 times over 3 into 24, that is 8 times. So 8 times. So this is the final answer, because 8 times 3, that is 24. Okay, then 5 times 3, that is 15. We look at B. For B, if you have zeros, okay, on your right of each number, the numerator and the denominator, just cancel this and this. So the new number will be 2 over 3. So we can proceed if these numbers add factors. So 2 and 3, this is the final. There is no number common factor apart from 1, which has no effect that can go into both numerator and the denominator. We go to the next one. We have 4 and 10. So 4 and 10. So the common is 1. 2 can go into 4 and 4 itself. We have 1. 2 can go into 10. Okay. Then 5 can go into 10 and 10 itself. So what is the common greatest, highest common factor? This is lowest common factor. Highest common factor is 2. Okay, so we can say equals 4 divided by 2 over 10 divided by 2. So this is how many times can 2 go into 4? That is 2. How many times can 2 go into 4? It's 2. How many times can 2 go into 10? That is 5. So this is basically the answer. Okay, this is the answer. So we look at now numbers, okay, with integer signs, and some are peculiar, but we need to get over this. So the first thing to do is to work out first the numerator, then denominator, then you follow the rules for fractions. So from here, what am I going to do? This is the same as -1 minus 3. So you go back to integers, okay, subtracting numbers like this. So you just say 3 minus 1, that is 2. You ask yourself, the numerically larger number as negative, so this answer will be negative. Okay, I've found for numerator. Then you come here, you also find for 8 minus 2, it will give you 6. So the new fraction will have -2 and 6. So this will be -2 over 6. So don't lose all those tips you learned under fundamentals of mathematics, integers. So what you have now here, you can't leave the answer like this, you reduce to lowest terms. So as usual, which number can go into both 2 and 6? So we know now that 2 into 2, that is 1, 2 into 3 into 6, that is 3. So you are dividing numbers with different signs, so the answer will be negative. So you put your negative in the middle here. So negative 1 over 3 is the answer. We come to this 0 minus 4. When you're subtracting, okay, a number from 0, the answer is always negative and that number. So this will be negative 4. 0 minus 4, you just write this number here, okay, with the sign. Then 2 minus 0, the answer is the same number. There is nothing you are removing from 2, so this will be 2. So in this case we have what? 2 into 4, that is negative 2 times, like this. Dividing numbers of different signs, the answer will be negative. Then 6 minus 0, that is 6 over, then this one is negative 2. Negative 2 into 6, different signs. This is negative 3, so this is the answer. Then we have the last one, 6 minus 0, the answer is 6 over, then 6 minus 8, that is 6. So if you look at this, both numerator and denominator, they have same sign, positive, so the answer will be positive. So this is the same as 6 divided by 6, 6 divided by 6, which is 1 over 1, and 1 into 1, that is 1. So basically this is how you manipulate fractions, and make sure that you address this problem once and for all. Thank you so much for your attention.